Hello. In this problem we are given y equals to 2 sine of 1/3 of x. We have to find the amplitude, period, and sketch the graph. The amplitude is always the positive or the absolute value of the coefficient of the given trig function. Since the coefficient is positive 2, the amplitude is equal to 2. The period is always calculated by taking 2 pi and dividing it by the coefficient of x, which is usually represented with b. So period is equal to 2 pi divided by the coefficient of b is 1/3, so 2 pi divided by 1/3, so p is equal to 2 pi. In order to divide by a fraction, we switch division into multiplication and flip the second fraction, so we get 3 out of 1. So period is equal to 2 times 3, 6 pi. So in order to sketch the graph, the first thing we need to do is to calculate the phase shift. And the phase shift is always calculated by taking the angle and set it equal to 0. So the angle is 1/3 of x is equal to 0. We have a 3 in denominator, so it's doing the dividing. The inverse of that is to multiply by 3. And whatever we do to one side, let's do the same thing to the other side. 3 and 3 will cancel, and we get that x is equal to 3 times 0, 0. So the phase shift is equal to 0. The next thing we need to calculate is quarter of the period. And in order to calculate quarter of the period, we just have to take period and divide it into 4 equal pieces. So quarter of the period is equal to, period is 6 pi divided by 4. 6 and 4 can be divided by 2, so we can reduce denominator and numerator by 2. And we get quarter of the period is equal to 6 divided by 2 is 3 pi out of 4 divided by 2, 2. So 3 pi out of 2 is our quarter of the period. The next thing we need to do is calculate 5 key x values. The first one is always equal to the phase shift, so x1 is 0. The second x is calculated by taking the previous x1 and adding quarter of the period to it. So x2 is equal to x1 is 0 plus quarter of the period is 3 pi out of 2. So x2 is equal to 3 pi out of 2. The next x3 is equal to, we need to take the previous x2 and add quarter of the period to it. So x3 is equal to 3 pi out of 2 plus quarter of the period, which is equal to 3 pi out of 2. This gives us x3 is equal to out of 2, 3 pi plus 3 pi. So we get x3 is equal to 6 pi in numerator out of 2. We can reduce this fraction and get x3 is equal to 6 divided by 2, 3 pi. The next x4 can be calculated by taking the previous x3 and adding quarter of the period to it. So x4 is equal to, x3 is 3 pi plus quarter of the period is 3 pi out of 2. We need a common denominator. 3 pi is out of 1. We need a factor of 2 in denominator. Whatever we multiply denominator by, we need to multiply numerator by the same thing. So 2 times 3. And we get x4 is equal to 2 times 3 is 6 pi out of 2 plus 3 pi out of 2. This gives us x4 is equal to out of 2, 6 pi plus 3 pi. And we get that x4 is equal to 9 pi out of 2. The next x5 can be calculated by taking the previous x4 and adding quarter of the period to it. So we get x5 is equal to x4 is 9 pi out of 2 plus quarter of the period is 3 pi out of 2. This gives us x5 is equal to out of 2. We have 9 pi plus 3 pi, and this gives us x5 is equal to 9 plus 3, 12 pi out of 2. x5 is equal to 2 goes into 12 6 times, so we have 6 pi for x5. Now we can populate the x and y table. So let's fill in the key x values. We had a 0. Second x was 3 pi out of 2. Then we had a 3 pi, 9 pi out of 2, and the period ended at 6 pi. First, y value can be calculated by taking 2 sine of 1/3 of x and substituting first x value into it, which is equal to 0. So we get y1 is equal to 2 sine of 1/3 times 0 is equal to 0. When you plug this into the calculator, make sure you are in radian mode. So 2 sine of 0 is equal to 0. If there are no shifts, meaning if you don't see plus or minus, sine function begins at 0, then it goes to the coefficient, which is 2, back to 0, the opposite of the coefficient, which is -2, and returns to 0 for the final point. But you should always be able to substitute the values and plug them into the calculator. So the second y value can be calculated by taking 2 sine of 1/3 of x and substituting second x into it, which is 3 pi out of 2. 3 and 3 will cancel, and we get 2 sine of pi out of 2. So 2 sine of pi divided by 2 is equal to 2. y3 can be calculated by taking 2 sine of 1/3 of x and substituting the third x value, which is 3 pi, instead of x. 3 pi is out of 1. 3 and 3 will cancel, and we get y3 is equal to 2 sine of pi. 2 sine of pi is equal to 0. y4 can be calculated by taking 2 sine 1/3 of x and substituting x4 in there, which is equal to 9 pi out of 2. 3 and 9 can be reduced by 3, and we get y4 is equal to 2 sine of 3 and 3 will cancel. 9 divided by 3 is 3 pi out of 2. 2 sine of 3 pi out of 2 is equal to -2. And the last y value 5 is equal to 2 sine of 1/3 of x, and let's substitute x5 in there, which is equal to 6 pi. 6 pi is out of 1. 3 and 6 can be reduced by 3, and we get y5 is equal to 2 sine. 3 and 3 will cancel. 6 divided by 3 is 2 pi. 2 sine of 2 pi is equal to 0. Now that we have a table, we can plot it on x and y axes. For x values, we had a 0, 3 pi out of 2, 3 pi, 9 pi out of 2, and 6 pi. The y values went between 2 and -2, so we have 1, 2, -1, -2. So when x was 0, we had a 0 for y. When x is equal to 3 pi out of 2, y is equal to 2. When x is equal to 3 pi, we have a 0. When x is equal to 9 pi out of 2, we have negative 2. And when x is equal to 6 pi, we have a 0 again. Once we plot all the points, we can connect them with the curve. And this is one period of y equals to 2 sine of 1/3 of x. That's all.